All right, today we're diving into something you probably haven't seen before, a document that mashes up ancient stories with, believe it or not, 6th grade math. It is a really unique lesson, so let's just jump right in.
So here's a question for you. It sounds like a bit of a riddle, right? What in the world could King Solomon, the legendary wise ruler, possibly have in common with the standard geometry class? Well, the answer, as we're about to find out, is the trapezoid.
So the material we're breaking down today is, at its core, a math worksheet. But as you can probably tell already, this is definitely not your typical homework.
Now our goal here isn't just to solve a few math problems, we're actually going to deconstruct how this lesson works, how it weaves together geometry and these old historical narratives to teach a pretty fundamental math concept. It's a really interesting way to teach.
Okay, so before we can really understand the stories, we need to crack the code. And in this case, that code is just the math formula for finding the area of a trapezoid.
So, what even is a trapezoid? It's a four-sided shape, a quadrilateral, that has one very specific rule. One pair of its sides has to be parallel. And you actually see them all over the place in the real world, in architecture and design, things like stages, ramps, even some cool-looking tables.
And here it is. This is the key to everything. The formula can look a little complicated when you write it all out, but if you break it down, it's actually super simple. It's just 3 steps. Step 1, you add the 2 parallel sides, the bases, together. Step 2, you multiply that number by the height. And then, for the final step, you just divide it by 2. That's it. 3 easy steps.
Okay, now that we have our formula, our secret code, let's see how this lesson actually uses it. This is where we get to the heart of the worksheet. Geometry for kings and queens. So our first problem is a big construction project for King Solomon himself. He's building this huge stage for musicians at the temple, and, you guessed it, the stage is shaped like a trapezoid. The worksheet gives us all the numbers we need. We've got the 2 parallel bases, which are 8 and 14 meters, and the height is 6 meters. So let's just apply our 3 steps. First, add the bases. 8 plus 14 gives us 22. Next, multiply by the height. 22 times 6 is 132. And the last step is to take half of that. And that gives us 66 square meters. It's a really cool way to see the formula work in a real, tangible story. The area of Solomon's stage is 66 square meters.
All right, let's move on to our next character, Ezra. In this story, he's using a massive trapezoid-shaped table to read the law out loud to everyone. It's another one of those practical, real-world examples.
Okay, for this table, the bases are 10 and 12 meters, and the height is 5 meters. We're going to run the same 3 steps, add, multiply, and divide by 2 to get our final answer.
And there it is, 55 square meters. You see, it's the exact same process, just wrapped up in a completely new story. For our final example, we're with Queen Esther. She's putting up this beautiful canopy for a huge royal banquet. You can just picture it, right? A big, elegant covering in a palace courtyard.
So let's look at the numbers here. The bases are 6 and 10 meters, and the height is 4 meters. By now, you know the drill.
And to get our final answer, 32 square meters. So you've got 3 totally different stories, 3 different sets of numbers, but it's the same exact math principle at work every single time. So we've seen how the lesson works, mechanically. But the really interesting question is, why teach it this way? And that gets us to the big idea behind this whole thing, designing with a purpose. This quote from the worksheet really tells you everything you need to know about the philosophy here. The lesson isn't just about shapes and numbers. It's actually framing geometry as a tool for creating things intentionally. It connects solving a math problem to this bigger idea of doing your work with excellence. And to really drive that point home, the worksheet brings in this verse from Ecclesiastes. It's making a very direct link between the math exercise and this moral instruction. Whatever you're doing, whether you're building a giant stage or just doing your homework, you should give it your all. All right, to wrap things up, the lesson ends just like most worksheets do, with a little homework. So let's take a quick look at the final challenge.
So here's your chance. Let's say a trapezoid has bases of 10 and 20 meters and a height of 5 meters. What's the area? Okay, let's see. 10 plus 20 is 30. 30 times 5 is 150. And half of that is 75 square meters. Pretty straightforward, right? A good final test of the skill.
And that really brings us to our final slide and what I think is the real takeaway from all of this.
We just walked through a math lesson, yeah? But the question it leaves us with is so much bigger. When you frame problems inside of a story, whether it's about kings and queens or, spaceships and aliens, how does that change the way we connect with what we're learning, and maybe even how well we remember it? It's definitely something to think about.